Hello everyone. In my last video, we have seen how to compile a simple kernel module for x86 architecture. In this video, I'm going to cross-compile the same module for Raspberry Pi ARM architecture. We'll see the dependencies now. In this series, for my experiment, I'm using Raspberry Pi Revision 2B board. So along with that, we need a cross-compiled kernel for Raspberry Pi. So because to generate the kernel headers, we need to cross-compile the kernel for ARM architecture. Let's get into the demo. Here I have written our modules already. So to cross compile our module for Raspberry Pi ARM architecture, we need to give this make command. So along with make, we have to pass couple of arguments. -c will tell your kernel headers path. Here I have already compiled my Raspberry Pi kernel for ARM architecture and I have created the kernel headers. So I have to give the kernel headers path over here. Then capital M will tell the modules path where you have defined your current modules. Then you have to tell the architecture. Here Raspberry Pi uses ARM architecture, so we have mentioned architecture as ARM. Then class compiler we have to mention. Here I'm using arm-linux-gnueabihf class compiler, so you have to tell this class compiler. Then finally you have to tell whether you are going to build a module or you are going to clean. So currently I'm going to build the modules. So it has generated the test underscore hello.ko module. If you want to check the file command on test hello.ko, here you can see this is built for ARM architecture. Now we have to copy this test underscore hello.ko module into your Raspberry Pi root file system. Here I have booted my Raspberry Pi machine and I have already flashed my kernel version into the target. So which is 6.1237. This is the kernel image which I have cross compiled for Raspberry Pi ARM architecture, and also I have copied my module test underscore hello.ko into the user directory. To insert our test underscore hello.ko module, I'm using insmode command now. Since I have already in upper user mode, no need to give sudo command over here. So just you can give test underscore hello.ko. See here, whatever the message we have put in module init, that messages are coming over here. So our module has currently loaded into the target. Now I want to check ls mode command here. See our kernel module is loaded over here. Also I want to show you the mod info command on our ko module. See, this is the file name, then our license which we have mentioned there. Then this is the where magic string. Here you can see it says compiled for ARM architecture, and also this is the our kernel version. Here if you see uname -a, this kernel modules kernel version and this kernel version, it has to be the same. For example, the demo purpose I have copied the x86 version of .ko file also. If you see here for x86 this kernel version is different, and for our kernel module the kernel version is same 6.237. This is the same version installed in the target. For example, if you are trying to load x86 hello.ko, then it will show invalid module format. See here, because it will check this where magic string. Since this kernel version is different, so it will be having a different where magic string, then the loading will not be successful and it will show the invalid module format. In the next video I'm going to explain how to put all these make commands into a simple make file, and from the command line if you give just make, then it has to compile your .ko modules. Thank you for watching.